This video lecture is going to go over vocabulary that's really key when it comes to communicating about phase changes. So in our phase changes lab, you ended up seeing a graph that looked something like this. And just to orient you, on the x-axis here is the heat added over time, and on the y-axis is temperature. This particular one is listed in degrees Celsius, and two important temperatures are listed, 0 degrees Celsius and 100 degrees Celsius. This leads me to believe that this is a heating curve for water, since 0 degrees Celsius and 100 degrees Celsius are really important points for water. We call this type of graph in general a heating curve that has heat added or time on the x-axis and temperature on the y-axis. And you will often see this shape that kind of has these zigzag lines through it. On this heating curve, we can add some labels for solid, liquid, and gas. Solid for water is below 0 degrees Celsius. Liquid for water is between 0 and 100 degrees Celsius. And gas for water is over 100 degrees Celsius. We call solid, liquid, and gas the different states of matter. And actually, there's a fourth state of matter that we can't see on this heating curve called plasma. We're not going to talk much about plasma in this class. Next, I'd like to highlight the process of getting from a solid to a liquid. We call this melting. Or going backwards, getting from a liquid to a solid, that process would be called freezing. Melting and freezing will happen at a very specific temperature. This temperature has a name called freezing point or melting point. For water, it's 0 degrees Celsius. Getting from liquid to gas, that process is called vaporization. One type of vaporization is boiling. This is when all of that substance turns from liquid to gas at the same time. It happens all at once. You might have also heard of evaporation. This is when liquid is turning to gas, but it doesn't necessarily happen all at once. Sometimes only the surface of something is evaporating. It also happens a little bit slower, and it happens at a slightly different temperature. Both boiling and evaporation fall under this process called vaporization, turning from liquid to gas. Going backwards from gas to liquid, we call that process condensation. Again, this temperature is very special. The temperature at which liquid is turning to gas or gas to liquid is called the boiling point or the point of condensation. For water, that happens at 100 degrees Celsius. There are two more processes that are pretty unique. The first one that I want to highlight is sublimation. This is when a solid turns into a gas without ever going through the liquid phase. In fact, this heating curve really doesn't even show sublimation. We would have to get rid of this middle liquid section in order to draw a heating curve for something that's sublimating. A solid straight to a gas without passing through liquid. You may have seen, for example, dry ice before, where it's like this solid piece of white, it looks like ice, and then there's vapor coming off of it. It kind of looks like smoke, but that's actually just gas coming from solid to gas right away. There is also deposition. Deposition is when a gas turns into a solid without ever going through the liquid phase. Again, a heating curve for something undergoing deposition wouldn't have this middle section of liquid. It would go from a gas back to a solid. An example of something undergoing deposition could be like water vapor in the air undergoing deposition to become frost on the grass. The frost, kind of the icy crystals that you might find in winter. And I want to point out that this entire heating curve is happening at a constant pressure. So this heating curve highlights 0 degrees Celsius for the freezing point and 100 degrees Celsius for the boiling point of water. That is only true at a pressure of 1 atm. ATM refers to atmospheric pressure. So for example, if you went to a different pressure, like you traveled from Lima to Cusco, this heating curve would actually look different. 0 degrees and 100 degrees would not be the freezing and boiling points in Cusco because there's a different atmospheric pressure there. Here is a slide with all of the key vocabulary terms listed out. Make sure that you're familiar both with where to find these vocabulary words on a heating curve and also the formal definitions. And that concludes our vocabulary lecture on phase changes.